Okay, here I am settings. So let's get started. So I'm going to try to learn how to solve some of these diode circuit problems. So let's see, 12 volt source goes plus minus. Then I have a silicon diode and then I have a open circuit. We have V0, we have a resistor, 5 kilo ohms. Connect these 2 points, and then we say we have a ground here. So now, how to solve this? We need to figure out the potential between these 2 points, but first we need to calculate the voltage after the potential barrier has been after the current flows to the diode, because it's on. So we do 12 minus 0.7, which is 11.3. So we have 11.3 minus V0 over the 5 kilo ohm resistor to figure out the current that is passing through this circuit. So let's see, times 10 to the power 3. So now let's figure this out. Yeah, is equal to 0. Let's see. Okay, and since we know V0 is equal to 0, we can rewrite the expression as 11.3 over 5 times 10 to the power 3, which gives us approximately 2.2 milliamps. 2.2 milliamps. Okay, this is not too bad. Okay, so in the next diode, since the current, the positive voltage is coming through the cathode, the diode is actually off, so you don't need to do anything for that. Okay, here we go. So now this is a little bit trickier. We have a 9 volt source. This is a positive source, and this actually passes through here. See. Okay, yes, there is a silicon diode plus a germanium, or whatever it's called, diode, and then there's a point here, there's an open circuit here. So V0 is equal to 0 at this point. There's a 4 kilo ohm resistor, and at the bottom here there is a 0 volt potential because we're at a ground node. There we go. So at the ground, voltage is 0. So how do we solve this? First, we need to do the following thing. We need to figure out the resistance that will be given from the silicon. I mean, not the resistance, the voltage drop from the silicon and germanium diode. So originally you have like a 9 volt point. Subtract that by 0.7 plus, actually let's say 0.10. Actually, let's say we subtracted by 1 volt, because the voltage drop caused by silicon and germanium together is equal to 8 volts. So we have an 8 volt potential minus a 0 volt potential over 4 times 10 to the power of 3 ohms, and that gives us 2 milliamps. That's our answer for this question. So let's see. Next question. So here we have a 6 volt circuit. This one is plus, this one's minus. It goes through 2 diodes. Number 1, we have a silicon diode, and we have a germanium diode, and they are connected here together in parallel. And then we have a 0 volt potential and we have a 5 kilo ohm resistor. Connect these 2 points together. This is our ground node. Just need to know voltage is at the node is 0. All we have to do is now account for which diode the current passes through. So we have to determine which is on. So as you always know, electricity travels to the path of least resistance. So this would be the germanium resistor, because it causes only a voltage drop of only 0.3 compared to the 0.7 of silicon. So this would be 5.7 divided by the 5 times 10 to the power 3 ohms, which is equal to how many amps? It is equal to 1.14 milliamps. And let's see if that answer is correct. Okay, the answer is correct. Now here we have another similar problem. As you can see here, it's the same thing, right? We have a 10 volt source, we have a resistor, 3 kilo ohms, we have a silicon diode, and we have a point where potential is 0 because there's an open circuit. And then we have a ground node here. We connect the ground node, and we have a 10 volt source. So how we solve this? So we have the potential at 2 sets. So what we need to do here is let's see, we need to figure out the current going through here. Let's see, I'm thinking you do 10. Let's see. Okay, I have no idea, but let's first find out the total current in the system. So we know that the voltage drop across these 2 points will be 10 minus 0.7, which gives us 9.3. Once we have this 9.3 figures, we add the resistances together. We have 3 kilo ohms plus 4 kilo ohms, which is equal to 5, 6, 7, yeah, 7 altogether, and that gives us how many current flowing through here? That's 7 kilo ohms times 10 to the power 3. This gives us 1.329 milliamps, and we take this figure to figure out the voltage going through the 4 kilo ohm resistor. So here we have the 4 kilo ohm resistor. We multiply it by actually 4 times 10 to the power 3 multiplied by 1.329 to the power 10 minus 3 is equal to, let's see, times 10 to the power 3 multiplied by 1.329 times 10 to the power to 5.316 volts. Let's see if this is correct. Okay, let's see. We have an 8-volt circuit here. We have a 3 kilo ohm circuit. We have a silicon diode, 2 of them in parallel. Current is entering the anode, so both of them are on. We have an open circuit, and we have a ground node here. So we need to figure out the total current. Since both of them have like similar resistance, electricity will actually travel through both of these diodes. So what this means is we have 1.4. We have a 1.4 voltage drop. So we do 8 minus 1.4. That gives us 6.6. Once we have this figure, we do 6.6 divided by 3. Six divided by 3. This gives us 2.2 milliamps. I wonder if this is correct. Okay, my approach was wrong. So let's think about it this way. components in parallel set the same voltage unless there's another source. So let's imagine this. So we have 8 volts minus the 0.7 because that's the lowest potential divided by the 3K. That gives us total current flowing through the circuit, and we do the 0.7. This is 2.433 milliamps. To figure out how much is going through each circuit, we divide that by 2. This gives us 1.217 is going through each of these circuits. So we have a circuit, we have 3 branching pads, we have short circuit in one, we have a diode, current is passing through the anode, so it's on. We have another diode, current is passing through the anode, so it's on. Resistor. We have V0. There we go. So one is germanium, one is silicon, and one is 2 kilo ohms, and another is 5 kilo ohms. So what we need to do is figure out the potential between point A and point B. See, we already know it's 0. Because when there's a short circuit, no current is passing through the infinite resistance essentially. So what we need to do is the potential at A minus the potential at B. Could do 16 minus 8, and this is equivalent to 24. Once we have this value, we can now actually calculate the total resistance as to to get the total current. So what we do here is we take 24 minus it by the voltage drop cost for every die component. In this case, it's 0.7 minus 0.3 divided by okay, so 2 kilo ohm. Okay, so plus 5 kilo ohm resistor, so 7 kilo ohms altogether. So we have 23 ohms divided by 7 gives us about 3.286 milliamps. Let's see if this is correct. Okay, this is indeed correct. So I guess we can give this a shot again. Okay, this is another unique question. Okay, so this one I think I might need an annotation. Let me just draw the circuit. Okay, both diodes are on for silicon. So we have 12 volts and we have 5 volts. We have V0. And we have 6 kilo ohms minus 3 volts. So what's happening here is we have a current. So let's make it like this. So current entering the node, current is entering the node here, and it's leaving the node. So we have minus 12, okay, minus 5, and we do minus 1.4, plus minus 3 divided by 6. Let's see if this will yield the correct answer. Divided by 6. That's 12. That's 5. That's 1.4. Let's see, divided by 6. You go to minus 3.567. Okay, so we messed it up. Let's see the mistake we made. Okay, it makes sense. So basically, right, our thinking was wrong. When the two dies and there's only one part for that current to flow, what happen is the diode, which has the overall higher potential after the voltage drop, will be the one that carries on the voltage. So here in this case it's 12 minus 0.7, which is 11.3, right? Minus 3, divide this by 6 kilo ohms, so 6 times 10 to the power 3 is equal to 12 minus 0.7 minus 3 times 6 times 10 to the power 3. Okay, so we get 2.383 milliamps. Is that what they got? Yep. Alright, this question is another trick question, right? So what we need to remember is, even though there are multiple parts, overall the current will flow through the part of least resistance. Okay, this means that given between the 2k ohm resistor and the 4 kilo ohm resistor, the diode will go through the 2 kilo ohm. So let me quickly draw this to clarify this. There we go, join these. We have an open circuit, 8 kilo ohms, the minus 9 volt source, 8 for 2 V0 and 12 volts. So what's going to happen here is that we have a 12 volt source, and then in brackets we subtract it by minus 0.7, right? And then we subtract this again by minus 9 volts, right? And divide this by the part at which the current is flowing. So this means we're going to do 2k ohms plus 8k, which is equal to 10 kilo ohms. And let's see what the answer will be. So I have 11.3 minus 9, 10. So we have 2.03 milliamps. Let's see if that's the correct answer. What is going on? It looks like there's a different way to do this. Okay, looks like I was wrong. Okay, this makes sense. So our mistake was very simple. So since these two resistors have diodes are the same and are in parallel, the potential between these 2 points are the same. So What we need to do here is calculate the equivalent resistor, which is 1/2 plus 1/4 to the power of -1 plus 8. Let's see if this gives us the right answer. Okay, so we got 2.175. Let's see if this is correct. Okay, perfect. We got the right answer, and this makes sense as well. I guess now we can give some of the actual practice problems a shot. So let's give this a go. Okay, continuing on to our actual questions. If I get the answers right. Okay, so I reckon the first step here is to determine which circuit is on and which is off. So I'll close this circuit. Minus 15 volts, 10 kilo ohms. So only one of these circuits is open because the current is coming through the cathode on the other one. So I have 15 volts here, 3 kilo ohms here, and we have a diode here. We have a point here, and we have 80 kilo ohms minus 5, 80 kilo ohms. So I have 3 points, A, B, C. We add them all up together. So at point A, we have let's say current entering is minus 15. Current entering is minus 5. Current leaving You go to 15 volts. Okay, so current leaving and entering. So let's add all of these up together. So remove this minus 15 volts here. Gives us minus 35 volts is equal to 0. And what we need to do here, subtract this by 0.7 minus 7 minus 35. It's equal to minus 35.7, and we divide this by the total current through the circuit, which is 93 kilo ohms. So minus 35.7 divided by 93 kilo ohms to give us, so this answer is wrong. Let's try this way. Oh, minus 15 okay, so we have current entering, minus 15 volts, minus 15 let's look at the solutions. Let's see how they did this. Check it off. You have minus V next I have minus 15 let's try it. So this current is leaving the node, current is entering the node, this current is entering the node. So I have minus 15 at the potential here. Set this is correct. Hmm?
It's too tight.
It's what? Okay, so I realized the previous from the analysis is that we have the directions of the current are wrong. So we want to start off with the positive potential. Since we have that here, we know that the current is going to be pulled from the right. That's what's going to create a negative potential here. For my purposes, I consider these as positive currents because I consider currents exiting or not to be positive. Yeah, this is positive, and currents entering a node to be negative, so this would be arrow down, and we have point VA. So let's get started. So current entering the node, so we have only minus 15, right? So we keep this as negative and this one as positive. So we are positive current, we do minus 15 minus VA. here you go, is equal to, since VA is the higher potential and these are low potentials, we put VA minus 2 volts as VA minus 5 volts. This become positive. T1020 SC stain over 3 minus X is equal to X plus 15 for 10 X plus 5 plus 80 T